we're going to see these things as graphs oftentimes. Okay? It's not always just going to be a bunch of points that they give us. They're going to give us graphs and ask us, is it a function or not? And then what is the domain and what is the range? Okay? So we've got to get used to looking at graphs and finding the same information. So the first thing, to determine whether or not a graph given to you is a function or not, you use what's called the vertical line test. Okay? So the vertical line test states that if a vertical line passes through more than one point on the graph of a relation, then the relation is not a function. So let's take a look closer here. So this is an example of not being a function. Obviously the blue kind of parabola looking thing is the relation we're talking about. Okay? And the vertical line test is the red line. Now, do you actually have to draw in a vertical line? No. You can imagine it. Okay? Because technically for the vertical line, we want that vertical line to go anywhere on the graph. Okay? You don't want to just test it in one spot and say, well, it works or doesn't work there. You want to think of it, well, would it work or not work everywhere? Okay? So, looking at this is an example of not being a function. So I'm just going to write down here, this is not a function. Okay, and trying to tie it together to what we did on the front side of your notes as far as looking at the points and stuff, I'm just going to make up some numbers here for our coordinates. So let's say that this point here is at 1 on the x and 4 on the y. Let's say this is 4 on the x, and let's see here, this is 3 and this is 5. So by doing that, I can now say where those 3 points are located. Okay, I've got that black point located at 1, 4. I've got the first red point located at 4, 3. And I've got the second red point located at 4, 5. And so looking at this now, what the vertical line test is showing us is that for this, because it's a vertical line, so it's talking about x values, for this one input, we are getting 2 outputs. So for the one input, we're getting 2 outputs, making it not a function. No questions yet? So okay, let's practice vertical line test real quick. So off to the side here, you can just look up at my screen. You don't need to write these down if you don't want, or by all means write them down if you want, but keep them onto the side because we're actually going to fill in the bottom of our notes tomorrow. Okay? So what if I have a parabola? What if I have a parabola? Do you think a parabola is a function or not?
Oh, yes, it is.
Yes.
No, it's not.
Okay. Now, first things first. In order to determine whether or not a parabola is a function by its graph, you have to be graphing parabolas properly. Some of you got very lazy on how you graphed parabolas, and you showed me that they would like curve back on themselves. Parabolas do not curve back on themselves. Okay? Also, parabolas, some of you would show the parabola as all of a sudden then going vertical. Parabolas don't actually ever go vertical. So, what a proper parabola would look like is it starts to get vertical, but it's always kind of getting a little bit wider, right? It's always getting a little bit wider. So something like that. So looking at that parabola now, are parabolas functions or not?
Yes.
They are. If your parabola opens up or down, like this one does, then yes, because no matter where I put a vertical line, it's only going to cross that parabola at one spot.
So that's what makes it.
All right, so this parabola definitely passes the vertical line test, so it is a function. All right, let's see here. What if we just have a straight line? Oops, let's change the color. Too late. What if I have a straight line? Is that a function or not?
Yes.
So, absolutely. Every vertical line I draw on here forever and ever, doesn't matter where I put it, It's only crossing that line in one spot, so this is a function. Well, think about that. Are all lines functions then? Well, all lines are straight, so don't tell me a straight line. What about a vertical line? Vertical line. Would a vertical line pass the vertical line test? No. Vertical lines are the only lines that are not functions. Okay? Vertical lines are the only lines that are not functions. Because obviously if I drew a vertical line and then did the vertical line test, our vertical line test would cover the entire vertical line, right? And so it intersects it everywhere, so it's not a function, okay? So every other line, though, is, okay? Other than vertical lines, every other line is a function. What about, let's see, we dealt with circles in this class. What about a circle?
No, because it would intersect.
It's not a function, yo.
So given a circle, you're saying not a function. I agree with you. The circle only passes the vertical line test at 2 spots. There's 2 points where the circle passes the vertical line test. It'll pass the vertical line test at the left and right point of tangency. That's a phrase from geometry. The left and right point of tangency is where I get a tangent line to my circle. That's it. That's the only places where the vertical line test passes on a circle. Every other place, it's going to cross at 2 spots. Question?
Would there ever be like a horizontal line test? Or is it just
So on the bottom half of your notes here, they say a function rule is an equation. So that's all it is. A function, or even written in function notation, it's just simply an equation like we've always dealt with. Okay? And for example here we have this line, y equals 3x plus 2. That is a function giving us the output of y and the input of x. Well, for function notation, it changes the y into an f of x. That's how we say that, is f of x. Okay? F of x does not mean f times x. It means y. Just like I always told you guys, if you see f of x, it means y. Okay? And it's a thing together. It's not multiplication. It's not f times x. So, f of x means the function where your input variable is x. Okay? That's what f of x means. It's the function where your input variable is x. And if we actually input something into the function, for example, if we want to substitute a 1 into it, then we would write that f of 1 equals 3 times 1 plus 2. Okay? So, for example, let's go ahead and look at this first guy down here. It says, for f of x equals negative 2x plus 5, what is the output for the inputs of negative 3, 0, and 1/4? So, we have our function, f of x equals negative 2x plus 5. And if I want to substitute negative 3 into it, I write f of negative 3 equals negative 2 times negative 3 plus 5. And then I simply go through and simplify that down. So negative 2 times negative 3 is 6, plus 5 gives me 11. Now, I do not change the f of negative 3. A common mistake students try to make is they say, okay, now I've got to divide by negative 3. You are not dividing by negative 3. This is a thing together. Okay? It doesn't get separated out. And why we do that is because we are then able to say that the function, when we plug in negative 3, gives us 11. Okay, if all I wrote was y equals 11, could you tell me what I plugged in for that? No, all you know is y equals 11. Okay? But if I tell you f of negative 3 equals 11, you now know that I plugged in negative 3 and the function outputted 11.
Wait, so do you have to plug all three of those in for 3 different times?
For this problem, that's 3 different problems. Yep. Okay? So we have plugged in negative 3, now let's plug in 0. So f of 0 equals negative 2 times 0 plus 5. So we get 0 plus 5, our output is 5. And we write f of 0 equals 5. Alright, it's basic substitution, we're just practicing a new notation. Okay? We're going to make sure to do f of 1/4 because I know many of you don't like fractions. So, f of 1/4 equals negative 2 times 1/4 plus 5. What is negative 2 times 1/4?
It's negative 1/2.
Negative 1/2. Very, very good. Now I've got to take negative 1/2 plus 5. How do I add fractions? Same denominator, so how do I get 5 to be a denominator of 2? Okay, so I make it a fraction by putting a 1 under it.
Yeah, you put a 1 under it, and then you multiply the bottom and the top by 2.
There we go. So therefore it should be 10 halves. Right? 5 is just 10 halves. There's my common denominator. So now what is negative 1/2 plus 10 halves? positive 9/2.
And we can just leave it like that?
Yep, I'm fine with reduced improper fractions. There's nothing wrong with that. Okay, so taking a look then at this next set, I'm just going to do one of these real quick. The whole point of this, again, if I plug in -2 into my function, f of -2 equals -4 times -2 plus 1. So I get 8 plus 1, or 9. The whole idea here is that I'm able now to say exactly what I inputted into the function. Because I know it's not just f of x, it's not y, it's f of -2. I know that my x coordinate is -2, and now I found out that my y coordinate is 9. Okay? I know that when I write it in function notation, because I can see both input and output. Now, something else you need to be careful of is don't confuse interval notation with a coordinate. This is a point. How do I know? Because I'm talking about inputs and outputs. Okay? Whereas what we were doing for the homework was interval notation for domain and range. Right? Even though they look similar, they mean totally different things. So please be careful on that. All right, one more thing I would like to do then. I would like to go through and give you another example to practice interval notation before we leave for the day. So let's take a look at a function that looks like this. We have an open circle, and then it goes like this. Oops, can't go that far, excuse me.
Does that mean it goes through, right? Or it's a bracket? Or no?
So it goes down, goes up, down again, up again, like that.
It's a function.
Okay, and we know that the coordinates of that open circle is at, let's say, -5, -3. So this is -5 on the x over here. This is -3 on the y. All right, so first off, yeah, function or not?
Function.
Definitely a function. Okay, if I take any vertical line and pass it left and right across that graph, it only crosses the graph in one spot. Okay, but now let's talk about the domain for this function. What is the smallest x value we could get here?
-5.
-5. But can the value actually be -5?
No.
No, because there's an open circle at that point. That means it could be -4.999999999, but it can't be -5. Okay? Everything up to -5, but not including -5. So we use a parenthesis. And then how about the biggest number we can get?
It looks like it is.
Infinity. It goes on forever in the x direction. So we go up to infinity. All right, then how about the range? What is the smallest y value we can get? -3. But can it actually be -3? No. Again, because that's an open circle at that point. So it's not actually -3. It can be -2.999999999, but it can't be -3.
And then it's infinity.
And again, it goes up to infinity. All right, our x values start at -5, but it can't be -5, and it goes forever in the positive direction to positive infinity. And our range starts at -3, but does not include -3, and goes forever in the positive direction to positive infinity. Okay? Questions on finding domain and range, or on function notation?